LRU Cache. So in this question, we have to design a least recently used cache. Now, whenever we say a key value pair, the first thing that comes to mind is a dictionary or a hash map, where we can hash the key values into buckets to get um, a value after getting the hash. So now in this, we have an eviction policy. We have to implement an eviction policy as well. So essentially, we have to, whenever there is a cache key that is accessed, at that point in time we have to move it to the end. So essentially, what we can, the eviction policy has to be last in first out, a kind of an eviction policy. So whenever we are accessing a key, we can move it to the end, or whenever we are uh, adding a new key or an existing key, at that point in time we can also move it to the end. Now, uh, a key which was the least recently added or accessed should get evicted whenever the size of the cache or the dictionary is greater. So the in Python there is something known as an ordered dictionary. So essentially it will do, it is different from a normal dictionary in two ways. That essentially we can move, so essentially the for every key there is a doubly ended, this is like a doubly ended queue for, so essentially we can move a key value to the end whenever we are accessing this one. These are the Python documentation, Python 3 docs. So an order dict is a part of collection. um, so essentially whenever we are adding an item, we can move it to the end. Similarly, whenever we want to pop an item, because we want to pop in last in first out manner, so we can always pop item. This will essentially, the pop item method will either pop the first or the last item. So we always want to pop the last item. um, Essentially we always want to move elements to the last, so we always want to pop the first item here. So let us start the coding. So we can define dictionary, and then there is a capacity. Now if key is present in self dot dictionary, then we can move this key to the end, and we can return otherwise we can just return -1, which is the default value. Now the idea here is that we can always define, the idea is that if key is already present in the self.dictionary, right? If the key is already present in this, then we can always move this to the end. right? And then we can override the either override or add a new value. And if this is a new value, then this will always be added to the end. Now if the capacity of the dictionary, right, is greater than, so if we have greater number of items than the capacity, uh, then basically we will have to pop dot pop item. So we'll have to pop item, and here the idea is that because we are doing pop item, like we'll always end up popping the last in first out manner, which was least recently added, that should be popped first. So we have some getting some error. Yeah, so here we need to add reverse thing last. Let's try to debug this. So initially auto detect is 1 1, then it is 2 2, and then we get the value. Now we put 3 3. So so we put 1, and then we put 2, and then we get 1, so we will put 1 at the end, then we will put 3. So 3 should be put at the end, and whenever we are popping, we should pop so we should just do last equal to false over here. Right, so last should be equal to false, and by default last is true actually. So yeah, that is the catch. So as we can see that this is now running fine, and then this is having a 700. Yeah, this is running, this is beating 99%. So yeah, we should be good with this. So the runtime complexity for this one in terms of item lookup is O of 1, because this is like a dictionary. Even in terms of put method, whenever we are putting a value, we are always so all of these steps, like getting the key value or moving this to the end or updating this value or popping the head, like the first item, these are all O of 1 items. So yeah, the runtime complexity should be O of 1. Let's try to rerun this. Yeah, it's looking fine.